This is the fifth behavioral design pattern from the Gang of Four Design Patterns book. This one is called Mediator Pattern, and it is a pattern you use when you want to set up loose coupling between a group of objects by keeping them from referring to each other directly. I'll start with a quick summary of what we are trying to accomplish with this pattern. The mediator pattern is a good choice when you are trying to accomplish the following. You have a group of objects that need to refer to each other. Exactly how the objects should interact is not known at compile time, or it may change at runtime. You want to direct all interactions through an intermediary. Okay, let's go through the points one by one. The key issue is that you have a group of objects that need to interact with each other. But the specific pattern of interaction is not known beforehand, or it can change on the fly. Perhaps because you're adding or removing objects from the group at runtime, or because the pattern of interaction between the objects changes due to external circumstances. If you try to code this behavior into the objects directly, you will get a very complex spaghetti of references between objects. You will also need to add code to each object to keep the references up to date. Sure, you can put this code in a common base class, but what do you do if the objects in the group have different base classes? You don't want to duplicate code. The mediator pattern is the solution to this problem. Instead of having the objects refer to each other directly, they instead only refer to the mediator. Each object communicates its intent only to the mediator, and it is the mediator which then notifies other objects. The mediator acts as a communication hub between all objects, and keeps all object references up to date. The mediator pattern offers a number of benefits. When you use the pattern, the objects no longer have to reference each other directly. In projects with lots of objects with complicated interrelations, the pattern will concentrate this complexity into a single mediator object. This simplifies your code enormously. The pattern also helps you handle changes in the network of object references. When the reference network needs to change for whatever reason, the mediator can handle it directly. The objects do not need to be aware of any change. This again simplifies your code and prevents code duplication. The mediator pattern also has a disadvantage. You might be tempted to set up a mediator object to handle communication between all objects in your application architecture. You could set up a messaging framework or a service bus and have your entire application interact through this single communication hub. On paper, this seems like a very clean architecture. However, when you do this, you are concentrating all communication logic of an entire application into a single object. This object then effectively becomes a God object, an all-knowing and all-seeing object that manages all aspects of your application. A God object is an anti-pattern. When you are concentrating too much functionality into a single object, then you are no longer using the benefits of an object-oriented architecture. You are also introducing a single point of failure, and you are making your code much harder to read and maintain. Here is the UML diagram of the mediator pattern. The communicating objects are called colleagues in the terminology of this pattern. There is one abstract base class called colleague that holds a reference to the mediator object. We also have two concrete derived classes called concrete colleague 1 and concrete colleague 2. These classes inherit the mediator reference from the colleague base class. Note, by the way, that you do not need to derive all colleagues from the same base class. All you need to ensure is that each concrete colleague holds a reference to the mediator, and that there is some kind of mechanism to initialize this reference. A parameterized constructor is the most common way to do this. So, if all of your concrete classes contain the reference and the constructor, then you do not need a common base class. On the left of the diagram is the mediator hierarchy. There is an abstract base class called mediator that defines common functionality. This is useful if you intend to have more than one mediator. The concrete mediator class inherits from mediator and implements the mediator functionality. All logic pertaining to communication between the colleague classes is here in this class. The concrete mediator holds references to every single colleague class and can implement complex communication patterns between the colleagues. I am going to demonstrate the mediator pattern by writing a simple chat room application. I will set up a single chat room where visitors can join and leave. Every time a visitor sends a message, it is broadcast to all current members in the chat room. You can see why I need the mediator pattern in this example. Without the mediator class, I would need each visitor to hold a reference to every other visitor in the chat room. The reference map would look like this. Every time someone enters the chat room, I need to add the reference to all other visitor objects. And every time someone leaves the chat room, I have to remove the reference. That's a lot of work. Now look at the mediator pattern. All visitors simply hold a single reference to a mediator object. The mediator is responsible for keeping all object references up to date. This simplifies the code enormously. I will implement the pattern with the following classes. Okay, let's take a look at the code. I'll start with the abstract visitor class. You can see that it contains a field of type abstract chat room. This is the reference to the mediator object. And there's also a field called name, which contains the name of the visitor. And here are the method declarations. There's a send method for sending a message to the chat room. You can see that the implementation simply calls the send method of the chat room. There's also an abstract receive method for receiving messages from other visitors. This method will be implemented in the derived visitor class. There are two more methods, enter and leave. These are for respectively entering and leaving the chat room. You can see from the implementation that these methods call the register and unregister methods of the chat room class. The concrete implementation of the chat room visitor is here. The class is simply called visitor, and it derives from abstract visitor. There's a constructor here for initializing the name of the visitor. And here is the implementation of the receive method. You can see that my code simply writes the received message to the console. Okay, now let's take a look at the mediator classes. Here is the abstract chat room class, which is an abstract base class that defines three abstract methods: send, register, and unregister. There's also a field here called active visitors. This field contains a list of all the active visitors in the chat room. The concrete chat room class is here, simply called chat room. It derives from abstract chat room and implements all three methods. Let's take a look. I'll start with the register method. You can see that it is very simple. All it does is add the visitor to the list of active visitors in the chat room. And here is the unregister method, which removes the visitor from the list. The send method gets called when a visitor wants to send a message to the chat room. The implementation simply calls the receive method for every active visitor in the chat room. And here is my main program class. The main program method sets up a chat room with three visitors: Tom, Dick, and Harry. Then Tom sends a message to everyone in the chat room, and both Dick and Harry reply. Let me run the program to prove that everything is working. I'm compiling the code now. And now I'm running the program. And there you go. Dick and Harry received Tom's message. Tom and Harry received Dick's reply, and Tom and Dick received Harry's reply. Everything works. Okay, here is a quick checklist that you can use to implement the mediator pattern. First, identify a collection of interacting objects that would benefit from loose coupling. Then encapsulate all object interactions in a new mediator class. Refactor all colleague classes to only interact with the mediator object. And finally, have the mediator dynamically reconfigure the object interactions when necessary. And here are some final comments. The mediator and observer patterns are very similar. Both decouple senders and receivers. The difference between them is that observer introduces more structure. In the observer pattern, all participating objects are clearly separated into two groups: observers and subjects. The mediator pattern makes no assumptions about the roles of participating objects, and is therefore more flexible, but also less reusable. You can also combine the mediator and observer patterns. In this combined pattern, the mediator object is responsible for object interactions, and you use the observer pattern to register, unregister, and communicate with participants. Okay, here is a summary of what we have learned. The mediator pattern sets up loose coupling between a group of objects by keeping them from referring to each other directly. The benefit of the mediator pattern is that it simplifies the map of references between participating objects. The disadvantage of the pattern is that the mediator can turn into a God object. The mediator and observer patterns are similar, but observer is more structured than mediator. This makes mediator more flexible, but also less likely to be reusable.